Good afternoon, friends. Now, I want to solve a question from last year's test paper of 10th class CBSE Mathematics Standard subject. In my last class, I have solved question from S3 of last year's test papers. So let us take that question paper. This is uh, of code 30/S/3 of last year. In this, I have solved question number 24 in my last lecture. Okay, this problem I solved. Now I want to continue, and I am not ready with the answer of 25th question. I'll do this later. So let me go to the next question. That is this. Section C, question number 26. A quadrilateral circumscribes a circle. Prove that the opposite sides of the quadrilateral subtend supplementary angles at the center of the circle. A quadrilateral circumscribes a circle means inside a given quadrilateral, you have got a circle which touches all the four sides of the quadrilateral. Prove that the opposite sides of the quadrilateral subtend supplementary angles at the center of the circle. Let us look at the picture. Yeah. So, this is question number 26. Right. We have taken quadrilateral A, B, C, D, right? It can be of any shape. And a circle is touching all the four sides of this quadrilateral A, B, C, D. Okay, we have got a circle. It is touching all the four sides of the quadrilateral. This side is tangent to this. 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 Touching means a line segment is said to be touching the circle means it is tangent. Okay. Now we are asked to show that opposite sides in this quadrilateral subtend supplementary angles at the center. Let O be the center of this circle. Okay. AB and CD form a pair of opposite sides and join these four vertices A, B, C, D with O, the center of the circle. So now these opposite sides, side AB subtends this angle. Side AB subtends this angle at the center. That is angle AOB. Side CD subtends this angle. That is angle COD. We have to show that these two angles are supplementary. Means their sum is 180 degrees. Once we would have got shown that, we can as well show that this pair of opposite sides also subtend supplementary angles at the center. Okay, for this pair, this is right. Yeah. This side subtends this angle DOA at the center, and this side is opposite to this side, and this side BC subtends this angle at the center. Okay, now we have to show that these two angles are, once we show these two are supplementary, as in a similar way, we can also show that these two are also supplementary. Supplementary means their sum is 180 degrees. So let us proceed to show that these two angles are supplementary. Yeah. So what we do is we'll join. Yeah. Okay. Let me erase this also. Right. We'll join these 2 points of contact. Okay, I am assuming capital E is the point of contact of this tangent with this circle. Similarly, capital F, capital G, capital H are the points of contacts of these sides BC, CD, and DJ respectively. Okay, now I'll join G and F with a line segment. Right? Then yeah. Yeah, I'll join this. Yeah, this is O. Center is O. Okay, center of the circle is O. I'll join G with O and F with O with line segments. So I got this radius, and I also have got this radius. Okay. G and F are points on the circle, and O is the center. Therefore, GO is radius. FO is also radius, right? We can assume radius is small r of the small r. Okay, we can assume radius of the circle is small r. So these two are same. OF and OG are equal to r. Therefore, they are of equal value. They are of equal length. Now let's look at the triangle OGF. Okay, in this triangle OGF, these two sides are equal. Therefore, they subtend equal angles at the third side. These two sides are equal. Therefore, they subtend equal angles on the third side. Their opposite angles are same because these two sides have equal length. Okay, this triangle is becoming isosceles. Now, let us call the point of intersection of GF and OC as capital I. Okay, I'm naming this point of intersection of OC and GF. This point is capital I. Now, I'll show that triangle OIG is similar to triangle OIF. Okay, we'll show that these two triangles are similar. Why? This side OI is common and side OG is equal to side OF, and these two angles are equal. Therefore, by SAS, these two triangles will be similar. Okay, let us, yeah. Once we have got this, the corresponding angles become equal. What are corresponding angles here? This is one, and these two are corresponding angles. Okay, this is the angle included by this common side and this side OF radius. Similarly, in this triangle, radius and this common side include this angle, that is angle GOC. Therefore, angle GOC is equal to angle FOC. Those two are equal. Let us call that equal value small x. Small x. Right? Let us name this equal value small x. So we get this angle is small x and this angle is small x. Okay. Similarly, yeah. What are these angles COF and COG? COF is the angle made by CO with this radius, okay, which is passing through the point of contact F. Similarly, this GO is making angle X with CO. Means this is the common side, or the vertex C is joined to O. This line segment is making with this radius, which is passing through this point of contact. This radius and the line joining vertex in the center are making including angle X. Okay, so here if you take this angle and if you join, yeah, let us join O with E. Okay, let us join O with E. Now this is yeah. Now, as before, we have got these two angles are equal. Now we can get this angle and this angle are equal. These are the angles between this this vertex joined to O, the line segment O, that is OB, and this radius vector passing through the point of contact. Okay, and let me call this value, the value of this angle small y, and then it is also equal. It is equal to the line segment BO making angle with the OE. right? Means this angle is also y. That's how we get angle EOB is equal to angle FOB. These two angles are equal. Similarly, similarly, let us join H with O, H with O. Okay. Now we can name, we can obtain, as we have obtained these two angles are equal to x, we can obtain these two angles are equal. Let us call that equal value small z. Okay. Similarly, here also we can obtain these two angles are equal. Say they are theta theta. Okay. Now let us say we have got 8 angles. Right? The angles between CO and the corresponding radii, which are passing through these 2 points of contacts. These two angles are giving 2 angles. Similarly, BO has 2 angles, equal angles, that are included by these two radii passing through these 2 points of contact. We are calling them Y. These are two Y's. These are two X and two Z and two theta values. So we have 8 angles in all. So if we add all these, we get right, x plus y plus z plus theta becomes right. All these 8 angles form a complete angle at this center, which is equal to 360 degrees. Means this is 2x, this is 2y, this is 2z, this is 2 theta. Therefore, 2 is common into x plus y plus z plus theta, right? Z plus theta is equal to 360 degrees. Okay. 2x, 2 is out, 2y, 2 is out, and 2z, 2 is out, and 2 theta, 2 is out. Okay. So 2 cancels in this 180 times. So we have x plus, x plus y plus z plus theta is equal to 180 degrees. What is 180 degrees? X plus y plus z plus theta is equal to 180 degrees. What is x plus y? This is x, this is y. Therefore, this is x plus y. This angle is x plus y. Okay. This angle is x plus y. Yeah. This angle is x plus y. There is angle between CO and OB. Okay, that angle is x plus y. So this is angle COB plus angle. What is z plus theta? This is z. This is theta. That is an angle between DO and OA. That is angle DOA. Right. This is 180 degrees. So right now. Now, what is angle COB? This is the angle made by this side BC. Okay, and this is right. This is angle made by BC. And what is this? This is angle made by AD. Angle made by subtended by made by AD. Okay, therefore AD and BC are making angles whose sum is 180 degrees. Means this angle plus this angle are supplementary. Okay, and this is a pair of opposite sides. So these two opposite sides are subtending two angles which are supplementary. So for this pair of opposite sides, we have shown that the angles opposite them, the angles subtended by them, and this center are supplementary. Similarly, we can show that for this pair of opposite sides, AB and CD, also make angles at this center which are supplementary. Okay, so we can further explain. Let us see. Yeah. Right. So how we have proceeded? Yeah. Let me do the working. So let ABCD be a quadrilateral and the circle and a circle and a circle and a circle of radius r, and center O B uh, O B. Yeah, let B, ABCD be a quadrilateral, and let it, and this circle be circumscribed. Be circumscribed by the quadrilateral. Okay, so I'm assuming that ABCD circumscribes this circle. Means all the four sides, all this implies all the four sides of the quadrangle quadrilateral touch this circle. Okay, so now let us join. Let us name the points of contact. Let E, F, G, H be the points of contact. Points of contact of sides AB. For AB is point of contact. For BC point, F is point of contact. For CD, G is point of contact, and for DA, H is point of contact, respectively. Okay. Yeah. Join these with the center. E, O, then FO, then GO, and HO with line segments, with radii. Okay, with line segments. In fact, this become radii. Okay, with line segments. Right. Then let us join G with O. G, comma F with line segment. Okay. In triangle OGF, OG is equal to OF equal to R, implies angle G is equal to angle F. Okay. In this triangle OGF, this is radius. Therefore, these two angles have to be equal. Okay. Now, can I erase this? Right. Okay. I'll erase this. Now, let us take the point of intersection of GF with OC. Right. Yeah. So let OC meet GF at capital I. Okay. Claim triangle OIG similar to triangle OI. Right. Triangle OIF. Okay. These two triangles are similar. Why? Because OI is common. And OG equal to OF equal to radius, and angle G is equal to angle F. Okay. Two angles are equal. One angle is right. The one pair of angles are equal, and the two pairs of angles are equal. Therefore, by SAS axiom implies triangle OIG is equal to triangle OIG is similar to triangle OIF. Okay. Yeah. There. So what do we get? Uh, that completes the claim. So from claim, what can we obtain? This implies angle GOC. Angle GOC is equal to angle GOC is equal to angle FOC. FOC. Okay. Say this is equal to X. Say. Okay. This is a pair of corresponding sides. They have to be equal. Say that equal value is X. Right. Now. Uh, yeah. Similarly, uh, right, we can obtain uh, y z theta as in figure, and and we have angle. Let us add all these. That is angle. What are these angle? What are these? These angles are GOC, right? And then yeah, COF, angle GOC plus angle COF plus, right? This is GOC, this is COF, and this is FOB, angle FOB plus angle BOE plus angle EOA, plus angle AOH plus angle HOD plus angle DOG. Okay. We're adding all these four angles. Angle GOC plus angle COF plus angle AFOB, this angle, and plus angle BOE, this one, plus angle EOA, this one, plus angle AOH, this angle, and then angle HOD, this one, plus angle DOG, this angle. Means we are angle all these 8 angles. Okay? Means, yeah, we have this is equal to is equal to uh, uh, so right, this is equal to x plus y is equal to z plus theta is equal to 2 into x plus y plus 2 into z plus theta, okay, is equal to, yeah, all these angles make complete angle at the center. Therefore, this is equal to 360 degrees. Okay. So when 2 cancels in this, you get 180 degrees. Therefore, x plus y plus z plus theta is equal to 180 degrees. Okay. All these 8 angles make a complete angle at the center of the circle. That's why we have this. Okay. Now, what is x plus y? What is x plus y? Yeah, x plus y is the angle made by side BC at the center. Similarly, what is z plus theta? Z plus theta is the angle made by AD at the center. Okay, therefore, therefore, this is what? This is the angle made by AD. Z plus theta is angle made by AD. This is angle made by BC. Okay. So this implies BC comma AD subtend supplementary angles at O. Okay. Means this is a pair of opposite sides, BC and AD. I'm sorry, this is AD. Okay. Similarly, we can show that the pair what is the other pair? AB comma CD. CD also subtend supplementary angles at center O. Okay, so this completes the solution. Thank you. Goodbye. So shall I recall? Yeah, what we have done? Yeah, we have taken an arbitrary quadrangle, that is ABCD, and then this is circumscribing a circle, means all its four sides touch this circle. And then we have to show that opposite sides subtend supplementary angles at the center. Okay, let O be its center and join these vertices ABCD with O with line segments AO, BO, CO, DO. And take the points of contact as E, F, G, H, right? And look at this triangle O, G, F. These two are radii, they are equal. Therefore, the subtend equal angles on this third side in this triangle O, G, F. Okay. Now these two angles become equal. After that, you compare. You call the point of intersection of G, F with OC, capital I. Now consider the triangles OIG and OIF. This becomes similar. Why? These two sides are equal. This is common, and these two angles are equal. By SJS, these two triangles OIG and OIF become similar. Now these two form a pair of corresponding angles. Therefore, they are equal. Say the equal value is x. Similarly, you can obtain that the angle between this radius and this line segment joining center with vertex y is equal to this angle made by this OB with this radius point passing through this point of contact. Similarly, this the angles between this radius and this line joining A with O and line segment joining A with O and is equal to this angle made by AO with this radius, which is passing through the point of contact, capital E. So these two are equal. Say they are equal to Z. Similarly, these two angles, angle DOH is equal to angle DOG. Say it is theta. Now, all these 8 angles form a complete angle at the center. Therefore, their sum becomes 360 degrees. Okay. And you have two x values, two y values, two z values, two theta values. So 2 is common. That cancels in 360, 180 times. So what is left is x plus y plus z plus theta is 180. This pair forms, this pair is the angle opposite to side BC. This pair of angles is the angle opposite to, the sum is the angle opposite to capital AD. Therefore, the angles opposite to the sides BC and AD add to 180 degrees. Therefore, they are supplementary. Okay. Therefore, sides BC and AD subtend supplementary angles at the center. Similarly, we can obtain sides AB and CD. What is the other pair? BC and AD. BC and AD are vertical ones. AB and CD are horizontal ones. These also subtend supplementary angles at the center. Okay. Yeah, this completes. Thank you.